In this video, we will solve exercises on the present value of an ordinary annuity in a step-by-step manner. You will learn the equation of the present value of an ordinary annuity, solving problems using a scientific calculator, solving problems using a financial calculator, as well as solving problems using the present value interest factor of an annuity, which is the table. However, if you're interested in understanding the concepts and theoretical explanations, you might want to check the other videos in my channel. So let's get started with the equation. So here we have PMT. This is the equal cash payment at regular intervals across time. And I should highlight here that it takes place at the end of each time period. And I is the interest rate, or sometimes it is R. N is the number of time periods. So let's get started by putting the equation in practice. Here is exercise 1. It says, John is the lucky winner of a $50 million cash prize, which will be paid to him in the form of $1 million at the end of each year for the next 50 years. Knowing that the discount rate is 12%, what is the current value of his prize? So let's start by trying to break down the information that we have from the exercise. It says he's a winner of a 50 million cash prize. I don't think we can use this for now. But it says he will be paid in the form of $1 million at the end of each year. I believe this is the payment. And then it also says for the next 50 years. This is the number of time periods. Knowing that the discount rate is 12%, the discount rate is the interest rate. And then, what is the current value of his prize? So we are trying to solve for the present value of an ordinary annuity. So let's use the present value of an ordinary annuity equation and then plug in the numbers. We have the payment, the interest, the number of years, like so. You might want to plug it all in your calculator or break it down the way I did. And then you'll get the answer, which is $8,304,498.488. I believe solving such exercises is very easy. The only thing you have to pay attention to is memorizing the correct equation. Now here's another practice. It says, Ben and Donna are determined that upon retirement, they will need to withdraw 50 grand annually at the end of each year for the next 30 years. They know that they can earn 4% each year on their investment. Then, what is the present value of this annuity? In other words, how much will Ben and Donna need in their retirement account at the beginning of their retirement to generate this future cash flow? So let's get started by looking again at the given values of this problem. $50,000 annually at the end of each year. So this is a payment. And then for the next 30 years, this is the number of time periods. What they will earn is 4% each year on their investment. This is obviously an interest rate. And the question clearly says, what is the present value of this annuity? So there is no doubt in what we should be doing in this activity. So we will start by using the present value of an annuity equation. And then plug in the numbers. We have the payment, 50 grand, the interest rate, 4%, 0.04, and then the number of time periods, 30. Once you plug them in your calculator, you will get $864,601.65. Now we've reached the second part of this video. In this part, we will solve the same problems using the financial calculator. So let me get started by showing you the keys we will be using. Here we have the compound button. Once you press it, you will get a list, and we'll go through the list later. Then we have the EXE button. This is the execute button. Once you press it, you can move between items on the list. And then we have the solve button. You press it once you move next to the missing component, but only after entering all the given numbers. So here is exercise 1 once again. We have a payment of 1 million, number of time periods of 50, interest rate of 12%, and we are trying to find the present value of an ordinary annuity. I want you to take your financial calculator and follow with me the steps. First, press compound. Make sure you delete any numbers already entered in your calculator. And then, where you will find set, make sure it is on end. Then, move to N and enter 50. 50. N is the number of time periods and 50 is 50 years. Then press execute. Then you will go to I. I is the interest rate, and here we have 12%. Enter it in your calculator as 12 and press execute. Then you will find PV, the present value. Skip it for now and we'll come back to it later. Then you will find PMT. PMT is the payment. Enter it as a minus figure, so enter minus 1 million and then execute. Then you will reach the FV. I don't think we need it for this kind of activity, so skip it. Then using the arrow, go all the way up to the PV and then press solve. And the answer will be $8,304,498.488. Here is exercise 2 again. You might want to pause the video and do it on your own and then come back and check your answer. So we have a payment of 50,000, number of time periods of 30, interest rate of 4%, and we are again trying to solve for the present value of an ordinary annuity. So let's do it together. Press compound, make sure you delete all the values from the previous activity, and then go to set and make sure it is on end. Then, where you'll find N, enter 30 and then execute. Then you will find I, enter 4 and then execute. Then you will reach PV, skip it and we'll come back to it later. Then you will find PMT, enter minus 50,000 and then execute. Then you will reach the FV, we don't need it for this activity. And then using the arrow, go all the way up to the PV once again and then press solve. And you'll find the answer $864,601.665. The third and final part of this video is on solving problems using the present value interest factor of an annuity table. This is the table you have at the back of your book probably. But before we get started, you have to make sure that you are using the correct table. So read the title carefully, because you might have a future value table, a future value of an annuity table, and so on. So go to the present value of an ordinary annuity table. Now let's look at exercise 1 once again. Here are the given values. To use the table, I will focus on only 2 values for now. The N, the number of time periods, which is 50, and the interest rate, I have it here as 12%. So I will go to the table. Here is the 12%, and here is the 50 years, and I will find the corresponding number, which is in this case 8.3045. What I will do now is to multiply the payments I have from the question with the present value interest factor of an annuity. The present value interest factor of an annuity is the number I have just found on the table. It will look like so, and my answer will be $8,304,498.488. This is the same as the answer we got using the financial calculator as well as the scientific calculator. So here is exercise 2. Try to do it on your own before I explain it. Pause the video. So again, here are the values I will try to find in the table. N, which is 30, and I, which is 4. So I have the 4% here, and here I have 30. number of time periods, and the corresponding number is 17.2920. Again, I will multiply the payment by the present value interest factor of an annuity. It will look like so, and my answer will be 864,600. Notice here that it is slightly different from the number we got earlier. Earlier we got 864,601, and this is because the numbers in the table are rounded. So sometimes these frictions will affect our answer, but in any case, the answer is considered correct. This is the end of this video. Thank you very much for watching. If you have any questions, you can leave them in the comments below, and I would like you to visit the other videos on my YouTube channel.